Hi, my topic is modeling of absorption in pristine and defective metal organic framework materials. So, in this study, I focus on the interaction between UIO66, both pristine and defective, and between UIO66 and IPA or nitrogen. The ultimate goal of this project is to understand absorption, diffusion, and reaction of chemical warfare agents in moths. We start with a small molecule as a prototype that is easy to study experimentally. So our experimental collaborators are using NMR, IR, and some other methods. So the goal for now is to compare with experiment. UIO66 has 12 linkers connected to for each node, organic linkers. So we not only studied pristine UIO66, but also structures with different defective levels. And because in real life, all MOFs has levels, and only MOFs with missing linkers can react with chemical warfare agent. So here's the protocol of generating defective UIO66. First, we delete linkers from pristine UIO66. The defect level we studied are 33%, 17%, 8%, and 4%. And after that, we neutralize the structure using capping groups. We tested formate and hydroxide group. And next, we are optimize geometry using DFT calculation in CP2K and compute atomic charges using DDEC6. So here is the different ways of adding capping groups. For hydroxyl group, there are two ways to add it. So deleting one linker will create two positive charges in the structure. In order to neutralize that, we add one capping group, two capping groups. So there are two ways of adding OH groups: trans substitution and cis substitution. And and it already proved that the lowest energy arrangement is the trans substitution. Here is different ways of deleting two linkers because the high symmetrical structure of UIO66, there are only two ways of deleting them. Energy difference between the two structure is 175 kilojoule per mole. And there are other arrangement of OH groups giving low energy than structure too. Hydrogen gun first we use at the beginning we use trap as the potential for the adsorbate. But the problem is the standard UFF or dredging LG parameters prohibit hydrogen bonding with polar adsorbate. So DFT calculation indicate IPA hydrogen bonding with both mu3 OH and added OH groups. Here is a plot from the AIMD simulation shows the bond between IPA and the framework. The reason why this happens is prohibits the hydrogen bond is because the Lagrange we use, you can see that the sigma value is pretty large. So the average, the closest distance between those two atoms is 2.8 angstroms, which is larger than the typical hydrogen bond length. So we modify the potential we use for the adsorbate. We use trap for like we use we use trap for mu3OH, but UFF for other molecules. After that, we observe the hydrogen bond. You can see from here. For pristine UIO66, the isotope is almost the same, but for defective UIO66, there's a noticeable difference at the low pressure level. Here is IPA isothermal pristine UIO66. The temperature is 291 Kelvin. And we use P divided P0 to count for temperature difference in experiment. Simulation, you will notice that like simulation and predict the loading for when P divided by P0 is greater than 0.005. Here is IPA isotherms for both pristine and defective MOFs.